Hi, we're from Group 2. As we all know, plastic waste has always been a huge issue as we use plastic in daily life, like when we're taking away food, when we're doing the groceries, when we're buying clothes. So today we're going to focus on how engineering can help reduce plastic waste problem. Before I get into it, I'd like to share some fun facts about plastic waste. Did you know that out of the 8.3 billion metric tons of plastic produced, 6.3 million metric tons has become plastic waste, and only 9% of this plastic has been recycled? 79% of it is accumulated in either landfills or is being littered, which will eventually end up in the ocean at some point. Researchers also found that if this trend continues, by 2050 there will be 12 billion metric tons of plastic waste, which is 35,000 as heavy as the Empire State Building, and the ocean will be filled with more plastic waste than actual fishes. So, the first way engineering can help is the ocean cleanup.
Okay, so for what is the solution for our problem? Engineering is the solution. Engineering can solve this solution. It is a clean up technology which will concentrate the plastic in the ocean before it can be removed from the ocean. The system consists of long floater that sit at surface of the water skirt that hang beneath it. As we can see at this diagram, this is the skirt. The skirt is used to prevent the debris from escaping the underneath and lead it into retention system. This entire system is supported by floater. This is the floater. This is the floater. Which provide buoyancy. The system use the advantage of natural oceanic force to navigate the patches, which also increase its survivability in harsh ocean environment. Wind, wave, and the current will carry the plastic, and the system and plastic is captured using sea anchor to slow down the system consistently. The system autonomously navigates the garbage patch for a extended time period, catching and retaining plastic in the center of the system. Once the system are full, a vessel acting as a garbage truck of the sea will periodically remove the plastic. That's all from me. We move to the next present.
Engineers can help to reduce plastic waste by making the plastic using natural biopolymers. The examples of natural biopolymers are cellulose and chitin. Cellulose can be found in trees, while chitin can be found in shellfish like crabs, insects, and fungi. The plastic flexible film is created by suspending the cellulose and chitin nanofibers in water, then spray them onto a surface in alternating layers. Once the layer dry, the material will be transparent and compostable. Professor J. Kersen Meredith, who led the research, said that the material can reduce up to 67% of oxygen permeability over some forms of polyethylene terephthalate, also known as PET. PET is the transparent packaging materials that one of the most commonly used in industry. Besides, with the amount of cellulose already produced and a ready supply of chitin, there will be enough material available to make the new films of viable flexible packaging alternatives. As we can see here, there are three main raw materials of making the plastic, which are petroleum, coal, and cellulose. From the three raw materials, only one of them are renewable, which is cellulose. Therefore, cellulose is the safest raw material of making the plastic and can help to reduce plastic waste.
Crude oil from plastic. A Japanese inventor, Akinori Ito, also realized that since plastic bags are produced from oil, they can be converted back into their original form. The crude oil produced can be used to heat generator and stove. It can also be used for gasoline when refined for car, boat, and motorbike. It is found that 1 kilogram of plastic can produce approximately 1 liter of oil, and the conversion process requires around 1 kilowatt hour of electricity, which would approximate 20 cents. The machine uses highly efficient pyrolysis, which is the transformation of a compound into a smaller and simpler compound under high temperature. It is able to process different types of plastics such as polyethylene, polyethylene, and polypropylene, but not PET bottle. The machine does not produce any toxic substance when fed with the proper material such as polyethylene, polyethylene, and polypropylene. Furthermore, the machine produces a small amount of inner char residue. Firstly, the process begins with the heating of the plastic. It is then fed into pressurized oxygen-free oven. It is heated to 427 degrees Celsius, which converts the plastic into a liquid. The machine then transforms the liquid into gaseous state. The gas produced is trapped and allowed to cool. The vapor condenses when cooled and forms crude oil. The crude oil that are formed by the machine is a mixture of gasoline, diesel, and kerosene and heavy oil.
So, in conclusion, engineering is a field that contributes a lot to help in reducing the plastic waste issue that has been bugging us for decades. We hope that more engineers can realize this urgent issue soon, and hopefully, we can also contribute to this issue someday.